So in TCP/IP, let me just say some other thing before we get to the TCP/IP model. We said that data that has been sent from PC1 may go through different networks or hops until it reaches the server in other hand. Now it is possible that some networks in between cannot handle the data that is bigger than a special amount of size, which we call MTU, or maximum transmission unit. So these data should be fragmented into smaller chunks of data. We call every unit of data that is able to transfer from one network or from one device to another device a packet. You may hear another things for the unit of data like segment or frame. Most of them are just the same. It's just in the different layer in a model we may call them differently. So when we say packet, segment or frame, or mostly packet, we mean the unit of data. Now in order for us to simplify this communication and how a packet is created, we have defined a model called TCP/IP. In the TCP/IP, we have 4 layers. The first one, from bottom to top, is the physical layer. Then we get to the second, which is the internet. Actually, let me just call the physical the network access. I will tell you the reason in a moment. So this is the network access layer. Because why? Because in the OSI we have 7 layers. So when we say network access layer, we mean that this layer is both physical, is equivalent to both physical and data link layer in the OSI model. Now then we have the internet layer. After that we get to the transport layer, and then we have the application. So let us just explain about how an HTTP request is simplified using this model. In order for some data or packet to get to the server, it should have the corresponding address of the server, both the IP address, which is a digital address, and the MAC address, which are physical address written on the back of every network interface card by that card manufacturer. You could see every network interface card as the ear of person when they want to connect to each other and they want to talk to each other. Now because the application, we said, is the HTTP request, this HTTP request will be delivered to the next lower layer, which is the transport layer. In the transport layer we have 2 main protocols, which are TCP and UDP. Because HTTP uses TCP to communicate, so in this layer a header, an additional information. So another definition, header is just some additional information to help different devices in between to get to the destination correctly. For example, we said that in the data sent from PC1, the number of port should be specified, which is equal to 80, so that on the other side the server looks at the destination port number in the data and says, well, this port number is 80 and I'm listening at the port 80, so I will accept it. So port number is one of the things that is added in the TCP header. So we say that HTTP, the application protocol, will be encapsulated by the TCP, meaning that this would be the TCP header. Then this packet would be delivered to the next lower layer, which is the internet layer. In the internet layer, another additional information would be added to the data that we have. So this is the HTTP, and then we have TCP header, and after that, in the next lower layer, the IP header would be added to the current packet. So the IP could be the IPv4 or IPv6. We explain about all of them in the next lecture. IPv4 or IPv6. Now, after that, in the IP header, what would be added is that the the source IP address and the destination IP address. Well, the source IP address would be the IP address of this router. Usually this router, the ISP will assign a public IP address to the router, and the router uses that to communicate with the outside networks using this public IP address. And for the inside network communications, the router or DHCP server will assign to different devices in the network a IP address that is called private IP address. So the header, in this header, the IP address of the PC1 would be added, and then when it gets to the router will change the private IP address to the public IP address. That this is called the NAT or network address translation. So in here, mostly we have source and destination IP address. As I said, we will talk about all the details in the different layers later on. Then this packet would be delivered to the lowest layer, which is the network access layer. In the network access layer, again we have HTTP, that the TCP header has been added, and also the IP header. So when this packet gets to the network access layer, another additional information is added that based on the protocol used in this layer, we call it the physical header, or let's say we have an Ethernet network, so this would be the Ethernet header. This is mostly the physical addresses added to the main data. So the source MAC address and destination MAC addresses are the 12 important bytes that are added in the Ethernet header. We would have 2 more bytes for the type of next higher layer protocol on the other side that we would talk in the next lectures. Now this would be converted to the bits, and then it would be sent to the router, and here the router will does what we explained before, and then it will forward the packet on the other side. The network interface card will receive this packet, and then based on the information on the different layer, it will just strip away the corresponding header in each layer and then send it to the next higher layer protocol. So we just said that what is a TCP IP model in a very brief overview, but in the next lectures we are going to explain exactly how things are done in different layers. But the most important thing in here is that if we know everything about networking and communication, we could use programming languages to create specific packets and then inject them. We have complete access over our packets. So in this course we will explore more about TCP/IP model and all the different layers in TCP/IP model which we just explained, and also how different information and fields are added in each of the main protocols in each layer. For example, the first physical layer we explained about Ethernet. We would talk about how different fields are added to the data and how the data is encapsulated and is received from the higher layer. And also we'll talk about the different fields in the IP and also the main two protocols which are in the transport layer, which are TCP and UDP. And after that we have a good understanding of networks in the detailed format that are mainly explained to you using the RFCs, the documents of the each protocol. We would start programming using Python, and we would explain for you the main built-in functions like bin, hex, and int, and also some other modules like bin ASCII, for you to understand how to convert different numerical types to each other. For example, hexadecimal to binary to decimal, and to each other using built-in functions in Python. And also we would talk about the struct module, and we use that to craft and create packets. And in Python you would understand that we would use the socket module to create a socket, and after that by using raw sockets, by entering different arguments in the socket method in the socket module and creating a raw socket, you would see that we have complete access over our socket and over our packet, how to create it and how to inject it. The full course is available in the link below, and you could go there to see the whole course.